It is showing us live. Okay, it is
Should I
now live.
open my
Okay.
open my PPT?
Just wait a minute, then you can start. Okay. Uh, Good afternoon, all guys. It's a third day of our FDP and advancements in IoT. So today with us, Dr. Himanshu Agrawal. He is from RMIT University of Australia. So I welcome him. I request him to take over the charge. Thank you, sir. Thank you so much.
Thank you. So, good evening, everyone. It is good evening here in Australia. It's almost 6:40 p.m. here. And I thank Dr. Sandeep and his team for making this arrangement and inviting me for day 3 session. So day 3 session is on this interesting topic on IoT networking and cloud. And if you talk about networking is very close to my heart as I obtained my PhD in networking from RMIT in 2010. So let me briefly introduce myself. I'm currently associated with Swinburne University of Technology. I'm working as visiting associate professor with IoT Lab, Swinburne University of Technology. So without delaying it further, let's start this session on IoT networking and cloud. I'll share my screen. Okay, so
Please, sir, show your screen. Screen is remaining.
I just shared it. Okay, I'll do it once again. Okay. Okay, sorry. Is it visible now?
Uh,
Okay. So is it okay? Okay. So when we talk about IoT networking, I think you are already aware of this world of IoT, wherein we have sensors, right? So you have a variety of sensors helping you to collect lots of data from the environment, right? So if you take a simple example of temperature and humidity sensor, for instance, you have infrared sensor, you have ultrasonic sensor, which is used for proximity and for range detection, right? So you have accelerometer, gyroscope, etc., right? So you can see here that on the left hand side, it shows you a variety of sensors, right? And then here, if you see in the middle, right? So you have all these boards, right? So you can see here you have a Zigbee, right? You have a Wi-Fi board, right? So in a way, now when you talk about IoT networking, you need to understand practically that if I have a data from my sensor, and if I uh, connect it to my device, microcontroller device, for example, Arduino board or Raspberry Pi, or you have maybe a Texas board, right? So you can use any microcontroller board. Now, what I'm going to do if I connect my sensor and I mean, if I interface my sensor and program an Arduino board, and now suppose I had to send this data through Wi-Fi to another device, right, or to my IoT platform, right? So there is where you need to understand that you have networking that comes into the picture, right? So networking here is how we can network these IoT devices, and there are various ways, right? So in my today's session, I'm going to discuss about these short range or the long range wireless interfaces, right? So you can see that I have my sensors connected to my board, microcontroller board, right? And then with my microcontroller board, I have my networking device connected to it, right? So you can see here, I have my Zigbee board, I have my Bluetooth, low power Bluetooth, right? Or I have my Wi-Fi board. On the top, you can see I can use a long range communication module as well, which is a LoRa module. I'll discuss about this, right? So together now you can see a sensor with my microcontroller board and my communication module, a wireless communication module, can together make my IoT sensor node. So whenever you talk about any IoT sensor node, essentially it comprises of your sensor interface to your microcontroller, and then you have a kind of communication attached to it, right? That could be a Zigbee or could be a Wi-Fi, or you have Bluetooth, low power Bluetooth, right? So I think this slide is important, and it is actually providing you a snapshot of how any IoT sensor node looks like. So I think now if you want to understand in terms of how these communication protocols you have seen in the previous slide, right? Some of these physical modules you have seen, they are basically classified as either local area network, right? So if you see that the market in terms of the IoT, the largest share in terms of the protocols we use in IoT these days is the middle one, if you see, right? The low power wide area network IoT protocols. Now, among all these communication protocols which one can study, one should have a focus on low power wide area network protocols specifically for IoT applications. You can see here that still 45% of the market segment in IoT applications is due to low power wide area networking protocols. The reason is these IoT devices are constrained in terms of energy, right? So that's why you need a protocol which consumes least amount of energy. Um, Also, you need a longer range to cover, right? So to reduce the overall cost of any project, because you have to deploy many sensors, right, to make a complete IoT platform for that application. For example, if you take a case of environment monitoring, pollution monitoring, right? So you need to deploy thousands of sensors across some geographical area which you want to study and do this environment monitoring. So to reduce the overall cost of this project, if you work on this, definitely if you have a module, sensor module, which can cover a longer range, you can deploy this number of modules, and overall cost of the project can be minimized to a great extent, right? So yes, so these protocols are basically emerging. If you see in the middle, we know about our short range protocols, wireless communication protocols. We also know about our cellular networking standards. Now this is a good slide if you want to see how these protocols are positioned in terms of the data rate and the range they cover, right? So if you look at this short range segment, short range wireless segment, you can see here you have potential candidates at Zigbee, right? So you have 802.15.4 IEEE standard, you have Bluetooth, right? And if you look at these two important protocols as a short range communication, wireless communication protocols, um, the data rate these protocols support is quite low, right? So if you look at Bluetooth, the Bluetooth can provide up to I mean, the new Bluetooth standards are supporting up to 1 or 2 Mbps data rate, right? But still, if you see the data rate, Zigbee is actually meant for low data rate applications, right? Now, and the range is also not much. So it's 10 to up to, you can say, 100 meters of range you can use. So 10 to 100 meter is a typical range in which you can use Zigbee and Bluetooth. Now, if you're looking for a higher data rate, you can see here Wi-Fi is a most preferred candidate, right? It can provide you a data rate in excess of 54 Mbps with new Wi-Fi standards, right? Now, if you are looking or if you are aiming for high data rate and high range in terms of tens of kilometers, definitely you have cellular network as your preferred choice, right? Now, the emerging low power wide area, as I mentioned in my previous slide, is emerging because it is consuming less power, and most of the IoT applications, as we have seen in the literature, as well as we have seen in terms of various practical IoT platforms, the data rate of most of these IoT applications is pretty small, right? So low power wide area networking protocols, they are fitting quite well into this space where you are aiming for longer range to cover for wide scale or large scale IoT application, right? So where you have got let's say hundreds of locations where you want to deploy your sensors, and you want to collect the data from hundreds of such locations, and you want to make your machine learning model to create some value out of this data. So in such cases, you can have this low power wide area networking protocol to make your application cost effective. So you can have a low cost IoT solution for such application where you have hundreds of sensors collecting data, and you want to apply some machine learning to get some value out of it. Okay, so now again, if you want me to provide you a brief background, I can just quickly go through this, how you have various wireless technologies starting from personal area network. So the innermost circle shows that you have personal area network, right? Which you have seen, you have two candidates, Bluetooth. Uh, Ultra wideband is another emerging protocol in the personal area networking. The reason is UWB is excellent in terms of interference response. So there is least amount of interference which you otherwise see in case of Bluetooth or Wi-Fi. So for indoor applications, for example, indoor localization, if you are working on some applications such as indoor localization, one can make use of UWB protocol. So these days, you have many companies now making those UWB beacons, same as you have Bluetooth beacons, and you can localize your indoor space. One good example is asset monitoring. So you can do asset monitoring using this short range or personal area networking protocol. The personal area networking protocols, as I mentioned, they are having a low data rate. Okay, so data rate, maybe in case of Bluetooth, you enjoy up to 1 Mbps, but even less than 1 Mbps, and the range is quite short. So if you take an example of Bluetooth, as I have mentioned in my previous slide, Bluetooth can provide you a range up to 100 meters, whereas in case of UWB, you can have a non-line of sight range up to 60 to 90 meters, around 100 meters, similar range, right? And they are best suited for peer-to-peer or device-to-device kind of communications. LAN standards we have studied a lot. There are range of IEEE local area networking standards in this 802.11 family. I'm not going to go into the details of this, but the best part of the Wi-Fi, IEEE Wi-Fi standard is it provides you a good data rate. You can see here 11 to 54 Mbps. So for those applications where high data rate is the requirement, you can make use of local area network. Followed by you have metropolitan area networks. There are several standards, again IEEE standards. One which is shown here, 802.16. You can enjoy even more data rate, and you have even a range, citywide range for metropolitan area networking protocols. Wide area networking protocols, I think we are already aware of the wide area networking protocol. Uh, some of these protocols you are already using with your mobile phone, right? For example, you have got your 3G, right? So that is your wide area networking protocol that can provide you an extremely good data rate as well. So I don't need to go in the details of now this personal area networking protocol, as I have already discussed about this in my previous slide, that you have got several candidates as Zigbee, Bluetooth, as well as infrared, right? So as long as your range requirement is within hundreds of meters and you are working on some applications such as indoor localization, as I have pointed out very clearly, if somebody is working on some project, as I mentioned, you can compare it with the Zigbee based system, and I think that could be a good study based on two personal area networking protocols. You can do a very nice research study based on the implementation of these two systems, right? One using one using Bluetooth, another using UWB. So you can then work on the indoor localization with the accuracy in localizing. So we know about Google, how Google provides you this localization for outdoor applications, and the error right now is in some meters, right? Around 5 to 6 meters maximum error, which is fantastic for outdoor applications. But this amount, I mean, the error in order of 5 to 6 meters for indoor application may not be suitable. We aim for the accuracy in order of let's say less than 100 centimeters, right? So in that case, UWB is quite accurate for localization in the indoor settings, right? So I think Bluetooth is gaining lots of popularity because it's quite affordable, right? So in the past few years, Bluetooth has gained popularity in multiple applications. Healthcare is one important application where people have made use of Bluetooth standard, right? So the reason is it is really low cost, and the new Bluetooth standards, as we have seen, BLE. So with the emergence of this BLE standard, it is consuming less power as well. Infrared is another, I think, short range wireless communication we have seen, particularly in robotics, right? Now the limitation of using IR communication is it requires line of sight, and and another potential disadvantage of using IR is it can't penetrate your walls. So yes, you have got certain limitations if you use IR. And another thing in terms of security aspect, if you see, the data transmitted between infrared devices is normally unencrypted. So that part is also not going in favor of this infrared, right? So local area network, I think we have already seen local area network and how we use local area networking standard. The one which is shown here is a wired one, right? We all use to connect our PC to the internet, right? Now, this slide is quite important for those who are already using RPi or Raspberry Pi module. Even though if you don't have a Raspberry Pi physical module, I suggest you can actually download the Raspberry Pi virtual machine, right? So after the end of my session, I can suggest you how you can download that you know Raspberry Pi virtual machine on your Windows operating system, right? So once you have that RPi virtual machine, then you can use it as a RPi physical module. Of course, you may not be having the GPIO pins same as you can enjoy with the physical module, but in terms of you know uh, collecting the data from the sensor and inserting into the database, right? So you can actually install this virtual machine, and then you can install your Microsoft, sorry, you can have this MySQL server, right? So you can have MySQL server, you can install web server on the virtual machine, and then you can use it as a physical RPI module. So all the other hardware interfacing you can do with Arduino. So sensor with Arduino along with the RPI virtual machine can provide you a similar feel as if you are using a sensor, a physical Arduino module, and a physical Raspberry Pi. Now this slide is showing you how you can actually configure the wireless LAN on your Raspberry Pi. So once you install your Raspberry Pi virtual machine, or if you are already using physical machine, physical Raspberry Pi module, you can just open your terminal window and type this command sudo iwlist wn0 scan, right? And it will open basically, your wireless uh, port. So you can see here that WLAN, this is the command which you need to use for checking whether your wireless is up or not. So you can see once I have my wireless network, which I can see here, check the connection by typing if config WLAN 0. If I type this command on the terminal window, right, then you see that details showing that my WLAN 0 is up. I can see my Ethernet address. I can see my IP address, right, with the mask. So you can see that, and you can see the transmit and the receive part of my packets. So that shows that, my LAN interface is up, right? So you can check it on your virtual machine for the wireless interface you have on your PC where you are running your virtual machine. Or if you are using your Raspberry Pi, which has got a Wi-Fi WLAN, you can check your WLAN by running this command. So when you configure your Wi-Fi on modules like Arduino or Raspberry Pi, right? So you see that you have got service set identifier SSID, right? And then you have these protocols. I mean, I'm not going to cover these protocols in this session, right? So this part is related to the security, and we will have another session in day 5. Okay, so on day 5, we have this session on security, IoT security. We can touch this part on day 5. Okay. So some of these Wi-Fi modules, some of you must have used it already, or those who haven't used, they may buy some of these modules. The most popular Wi-Fi module, which is very cost effective, is ESP8266, right? So this is the one which is quite widely used with Arduino, right? So if you are using Arduino module uh, as a microcontroller module, right, the one which is quite popular and easy to program with range of sensors, you can think of using this Wi-Fi, and you can connect it with your Arduino board for making Wi-Fi communication. So the way you do it on Arduino is how you include that header file with the Wi-Fi, right? And then you see that you can so you have to run these lines of codes in your Arduino Sketch, right? So whenever you program your Arduino board, you have to open a sketch, right? And then you do coding uh, for the sensor you interface with the Arduino, or the Wi-Fi module you connect with the Arduino board, right? So you can see here that few lines of codes here. You can see that it is using this as a character SSID, and then I'm using it as IoT programming, right? So then you use the IP address, subnet mask, right? IP address of the gateway. So this information you have to write as a code in the Arduino for this Wi-Fi. Okay, so as I said that for IoT, I think one needs to understand that um, the new standards or the emerging standards on low power wide area networking protocols are very important, as if you are working on some IoT application, you are basically aiming for large scale deployment. It's not like just placing few sensors. You may be interested to deploy these sensors on large scale, a scale in terms of hundreds to thousands of sensors for one application, right? So when you have got such a large scale deployment as your objective, then definitely you need to work on the low cost solution, right? So if you are providing, this I mean, if you have this as your project which you want to work for some industry, definitely, the industry would be interested only if you say that I'm providing a low cost solution using IoT technology. So IoT technology is becoming popular because you can provide a low cost solution by collecting data, and then you do the data analysis on the data you collect, right? So low cost sensing solutions can be developed with the help of which you can collect your data, and then you can deploy your machine learning model on that data, right? So wide area network, before we talk about low power wide area network, I think the wide area networking standard, we need to first review that you have several wide area networking standards. Cellular is one such standard, right? So wide area networking standard is the one which covers a wider range, right? Where the range is in order of kilometers. If you look at a city-wide network, definitely a city, a metropolitan city is basically is having a large, you can say, area. Okay, so a huge geographical area. So in that case, we require a protocol which can cover longer range. So wide area networking protocol is definitely is the category in which now we see that we have emerging low power wide area networking standard for Internet of Things. So now, as mentioned before, that the the protocol is aimed for long range communication, and it supports those applications where the requirement of the data on the data rate is not high, right? So we are looking for the applications where the data rate is very low, right? So when you collect the data from the sensors, you have very low data rate, ranging from you can see here from 0.3 kilobits per second to 50 kilobits per second per channel, right? And long range, as you can see here, which varies from some geographical area in a city. So of course the aim is to cover 5 to 10 kilometers using that protocol, right? And low power, that is the most important part, as we have seen that the prime requirement with any IoT sensor device is to have the device, I mean, any protocol that should consume the least amount of power, right? So when we say a sensor node, as we have seen in the first slide, a sensor node comprises of a sensor with an Arduino board, and then you have a communication module. For instance, if I am using a communication module which is using low power wide area networking protocol, so one such module is LoRa module, right? Or Sigfox or NB-IoT, you will see. So if I am using one of these LP-WAN modules, definitely this LP-WAN module is consuming the least power, right? So apparently, uh, I program Arduino and interface it with the sensor to collect the data, which I can send it to my server, right? Maybe like once every hour or so. So if I'm collecting my data, I would like to make this node operate for years, right? Since my node is powered by batteries. So the drive towards using this low power wide area networking protocol is because we are using batteries to power such small sensor nodes. And we expect these batteries to last for years. Okay, so this makes this application of low power wide area networking protocol very important, especially for many applications where we have this aim of large scale deployment using low cost IoT solution. Okay, so you can see here it is low cost, and LPWAN protocol is quite simplified, lightweight, and it reduces complexity in the hardware design. So one such LPWAN module is wireless communication module for long range low power applications. You can see here. So this is the one which was first introduced in 2009, right? And you will see that most of the European smart city IoT applications are basically using this Sigfox. So this was the standard developed in France in 2009, right? Communication standard, and it was basically quite popular. I mean, still covering many areas, but now we have got few more um, uh, candidates, few more modules, right? Now, Sigfox is also covering, a substantial part of Australian community, and they have a partner here as Thingstra. And the frequency band is basically, we use this ISM radio band for operation, right? And the objective of using this Sigfox as a low power wide area networking protocol was to use for the devices that need to be continuously on and emitting small amount of data. And you can see the most important applications covering this Sigfox, use of Sigfox is utility, basically, right? So you can see electricity meters. So second candidate under this low power wide area networking protocols category is LoRa, right? So LoRa is another important standard which is used for long range, right? So LoRa is actually patented as a digital wireless data communication technology, right? And it competes fairly well against other low power wide area networking protocols, right? So you can see that the data rates are quite low here. 50 kbps is the range you can achieve. The important thing with LoRa is you have the range of operation which is below 1 gigahertz, right? So I mean, if you have a frequency of operation other than 2.4 gigahertz, of course, you have less interference, because if you talk about 2.4 gigahertz, most of these wireless communication protocols, they use 2.4 gigahertz. It is a very crowded space in terms of frequency, right? So if you are making any standard, and if the frequency of operation is 2.4 gigahertz, it is quite crowded and it creates lots of interference, right? So 868 megahertz, 433 megahertz, or 915 megahertz, these are the three frequencies we use with LoRa in different parts of the world. So the topologies which one can use with LoRa, you can have point-to-point communication between two devices, right? You can see here, and that's how you can actually make use of LoRa here. For instance, you have a farm field, right? And you are working on smart farming. Now, that smart farming application could be based on deploying multiple soil sensors, collecting soil data, right? Soil, I mean, you can check the nutrients in the soil basically using a soil sensor. You can check the temperature and the humidity, right? So let's talk about these two sensors deployed in the farm field, collecting a farm field data. You may have a drone also, right? The drone which is capturing some video data, right, and providing you some images of these um, uh, crops, right, every hour or something like that. So you can have the data from 3 such different sensors, and you can make use of the sensor data fusion to help farmers, and you can make a prediction about some yeah, I mean, if there is some disease in the crop, so you can basically collect lots of data and you apply your machine learning model, and you can predict about this disease before it actually happens. So this can definitely save, the crop, and can benefit the farmer, right? So apparently this can result in better yield from the same farm area, right? So yes, this is one application where I can make use of my sensors. I mean, each sensor node, as I said, comprises of a communication module. And when I use my communication module as LoRa, that LoRa module can communicate with another module which is placed in farmers' premises. Now, in most of these Western countries, farmer is not living next to his farm field. He lives quite far, right? So maybe like few kilometers, or in some cases maybe half an hour drive. So yes, they have got like huge farm fields, and then they live little far from their actual farm field. And in that case, we may aim to use such long range communication standard. Now, in case of India or other developing nations, they're also like a farmer may not be living next to his farm field, but maybe like half a kilometer or maybe a kilometer away from his farm field. So in that case, this could be quite useful to have you know um, a LoRa based communication, and then you provide some kind of information on the farmer's premise, so he can see few things, same as like he can watch it on his mobile. So you can develop a mobile app, so he can simply watch few things about what is actually happening in the farm field, right? So you can provide a very nice user interface for this farmer, um, in a way so that he can understand things actually happening in the farm field. So without actually visiting multiple times, he can have the status of everything on the farm field. So this is one good application. Actually, you see here that two LoRa modules are communicating with each other. That's how you can make use of LoRa code inside your sketch, right? So yes, this is like again another view of how you can make use of this LoRa as a communication, long range communication between two devices. So as I said, like it's not just Sigfox or LoRa. I mean, these two protocols are quite popular, but there's another emerging protocol called Narrowband IoT, right? NB-IoT. Now, if you see, you have got a very cost-effective Arduino module. You can see here, it is shown here, Arduino MKR NB1500. So if somebody is interested to develop a sensor node using this low power wide area networking protocol, you can simply buy this Arduino MKR NB1500, and you can connect it with your Arduino board, and you can make your module to send data over a distance of few kilometers, right? So this is another potential, low power wide area networking protocols, and it has got a wide usage these days. Now, if we talk about Australia, or in this is Asia Pacific, you have Australia and New Zealand. They are basically we have telecommunication provider, major telecommunication provider is Telstra, same as we have BSNL in India, right? So we have these telecommunication providers making use of such module, narrowband IoT module, right, for various IoT applications, right? So NB-IoT is quite popular for applications where you have indoor coverage. For example, as I said, farm fields or dairy farms, right? So if somebody is aiming to provide low-cost IoT solutions for dairy farms where you are having milk, right? And the farmers struggling to make a proper supply chain of the milk products, right, to the supermarket, right? So in that case, There also you can find a use of such low power wide area networking modules along with your sensor, which is used um, to address your potential problem, right? Yeah, this slide is just used to show how in Australia we are making use of this NB-IoT, and that blue part shows the coverage. Of course, the Australian population is only on these areas, right? So most of the Australian, you can see where the population is. You have got wide coverage using this NB-IoT. So the last protocol which I think I need to cover when we are talking about IoT short range or long range protocol. Zigbee is one of the most widely used protocols in the wireless sensor networks, right? Now, since we know about Zigbee, and Zigbee is possibly the one which I think almost all of us must have used or have discussed while talking about wireless communication protocols, right? So this was like one of those uh, few protocols in the wireless sensor networks being used for many applications, providing coverage up to 300 feet or 100 meters. And the best part is it is low power, low cost, low power. So this was the protocol which was quite widely used for, I mean, applications having a very small geographical area. For instance, if you are working on some water quality and you are using water quality sensors to monitor the water quality in a reservoir, right? So you can use multiple nodes making communication using Zigbee, right? So you have a data rate which is not high. So Zigbee supports up to 250 kilobits per second, which is fantastic, right? So I think most of the applications on wireless sensor networks in the 2000, or I mean before 2010, we have made use of Zigbee, and we still use Zigbee, right? So you have seen that the Zigbee module, when you use it with the Arduino board, is having this RF antenna, right? Which so you use Zigbee at this popular frequency band at 2.4 gigahertz, crowded band, right? And this is a typical I mean, topology in which Zigbee operates, right? So you have a coordinator node and various, you can say, routers, right? So the mesh topology, right? It does not operate in peer-to-peer. Rather, it supports mesh network, right? So you have a coordinator node, and then you have various routers routing traffic, and then you have your end devices, right? Now, so the next part of my session is, I mean, on the IoT networking itself, is based on uh, introducing you to this what you call SDN, software defined networking. So I'm just introducing you to software defined networking. I thought like this is an emerging, you can say, networking technology uh, for IoT or industrial IoT, to be precise, right? Now, what happens when you talk about a traditional networking, right? So you have seen that when you use a router, the control plane and the data plane, they are available on the same router, right? So when you see a traditional network, so you have a picture of all these routers connected to, I mean, more routers, right? So it's basically like you have routers in your premise connecting to core routers, and then apparently connected on the higher level of hierarchy. But definitely, it's like a distributed kind of network of routers, right? Now, the challenge with such a scenario is like when you have the control plane and the data plane running on the same router, and the routers, they are manufactured by various vendors. For instance, you have Cisco as a major player, you have Juniper, right? So you have other companies as well. So two major players, if I mention here, Cisco as Juniper, and of course you are many more. And if you deploy, your router from various vendors, and of course organizations are using routers from other vendors. So it may create, some interoperability issues. For instance, you have, OS supported by Cisco router, another router supporting different OS. You can see that it may create some interoperability issues. Another issue is like if some policy changes, now for such a highly distributed network of routers, it can become so difficult to update such change on various routers, right? So this makes apparently the network management task very difficult when you talk about traditional networking, right? So software defined networking is an emerging standard, you can say, uh, 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 network control technology, right? Where we decouple the control plane from the data plane. So all you do is you separate the control plane and you make a SDN controller, right? So what you do is you have a SDN controller which runs the brain of your networking, right? So basically it is the control part which is the brain, and then you use the data for forwarding purpose, right? So you use a SDN controller that stores the intelligent logic, or you can say it stores basically the control logic. Now the reason why we are doing this, again, we want to simplify, the forwarding part, right? So all you can do is, so if you again compare it with the rules you write on the router, so every time you write those rules that my data should be forwarded from, this machine having this IP address to another machine having some IP address. So from A to B, if you want to send your packet, you define that rule, right? So in this case, you write that rule. I mean, you can program it on the SDN controller, and on the lowest side, or on the device side, or on the infrastructure side, do only simple switches or lightweight switches, or you can call them simply dumb switches, right? So the networking devices are quite lightweight, very low cost, right? You can say lean devices, right? And all you can do is you can write those rules on the SDN controller and can make the network management task quite easy. And this essentially offers a flexible programmable architecture, right? So you can write rules for packet forwarding. You can write rules for dropping packets, something which you do with the firewall. So there is no need to have a hardware firewall now when you look at this software defined networking, right? So in terms of managing various networking devices such as router, firewall, right? So all you have is you have a SDN controller, and then you have got simple or very lightweight, low cost SDN switches, right? So if you see this slide, I think this slide gives you a better view of how you actually see a traditional network, right? So in the traditional network, you have got the control plane and the data plane. So this is actually a router. Let's say this is router 1, this is router 2, router 3, router 4, and they are connected again to another router, let's say core router, and the core router then connects to the outside internet, right? And of course they are apparently they are actually now sending your packet through another router to that machine, right, which runs that application. So you can see here that the SDN controller is actually forming now is like a brain of this SDN, or software defined networking, right, where you have all these networking devices which has only the data plane now, right? And all the control plane which you can see here from each of these routers is now available to SDN controller, right? So something like you have a network manager, so I can actually use a network manager at the SDN controller, right? Right. So you can understand that I have my applications. So using the API, this is called a northbound API, right? So the API, application programming interface, which can connect this SDN controller to all these applications, right? Business applications. So this makes the overall operation of your network as intelligent network. So the reason why I covered this small, information about SDN is SDN is quite emerging in terms of making network intelligent. So this slide gives you a detailed view of what you have inside this SDN controller, various modules. You can see that I have got my plugins to this southbound interface. So you can see that the terminology we use here is a northbound interface to connect my SDN controller to the application layer, and southbound interface to connect my SDN controller with infrastructure layer, where I have all my networking devices, such as you can see I have got my open flow. So in the SDN, we make use of this terminology called, we have a protocol called open flow, right? So the open flow protocol is implemented here in this southbound interface, right? So you can see that I have my northbound interface, which is connecting to various applications such as like flow optimizers, right? You have got network bandwidth app, load balancer, right? Some management applications, policy enforcement apps. So all these apps are running at the application layer, having interaction with this SDN controller using northbound API. Okay. So yeah, I think um, in terms of this SDN and IoT, now if you combine them together, because now this is very important, we are talking about IoT. Your overall FDP is on IoT or advanced topics in IoT. So this is one of those advanced topics. Now I thought when I'm talking about networking, it is quite important to know about this, right? So how this SDN, because the next question comes, okay, fine. We understand that SDN answers to some of these challenges which we can see with the traditional network, right? So something like network management is like one of those challenges we have seen already, right? If something changes in terms of policy, um, it's quite difficult to update on such a highly distributed traditional network of routers. Quite easy to do it on the SDN controller, because SDN controller has the global view of the entire network, right? So we have that SDN controller, which is actually sitting on the top of all these networks. You have access network, you have edge network, you have core network, right? So all these networks are actually connected to the SDN controller, and that way SDN controller provides you a global view, right? So there is no such issue of how that change in any policy which you have to map it in router is having difficulty of updating on many such routers, right? Another important thing when we talk about IoT, and now when we combine SDN and IoT or SDN and industrial IoT, you will see that IoT applications have, uh, the requirements in IoT applications are quite dynamic, right? Now, what does it mean by dynamic requirement? If you see the traffic, IoT applications may have real-time traffic requirements. For instance, if you talk about industrial applications, so these industrial applications may have mission-critical latency-sensitive requirements, real-time requirements. It could be an autonomous cars or autonomous systems in industry, right? So in order to have these autonomous systems in industry working in collaboration to accomplish some task, right? Now this is a kind of IoT system, right? So the requirements are quite dynamic here when you take such cases, or you can have uh, non-real time traffic, the other IoT applications not having any latency sensitive requirements. So the thing is, if you network is not suitable here. I mean, it's quite important to understand here, because routing in the traditional network is based on writing static rules, as I said, right? But these rules may not work when the requirement is quite dynamic. So this can be done if you have, you know, software-defined networking, which is programmable, right? So all you can do is you can program these rules on the software-defined networking controller, right? So of course, SDN and IoT or IIoT, if you see, is now becoming next important thing. The reason is you have, you know, how this SDN is now addressing to various challenges, such as like network management challenges, resource utilization, which is another important challenge, right? And then you have, so resource utilization here refers to making, I mean, use of the network, right? So network performance, specifically, we are talking about the, the resource utilization, which can be improved using SDN. So security and privacy is another important thing. Out of all these challenges, I'll pinpoint on this at the moment. As we know that in IoT applications, since you have got multiple parties, right, in any IoT applications, now all these parties can make use of your data, right? When you have a multi-vendor kind of system where you have the devices coming from multiple vendors, so is the case that you have these vendors having access to your data. So somehow, you know, privacy uh, is an important challenge for such IoT applications, and lots of research work has been done and is still in progress on privacy preserving analytics for IoT applications, right? So with flow based, so SDN supports, yeah, I mean, there is one important thing that SDN provides flow based routing. Now, because of this flow based routing, you can essentially address to these challenges which are there in the traditional routing on part of security and privacy, right? So this can be addressed by SDN to a great extent, right? So it's quite interesting that how SDN can work now for various industrial IoT applications. And if you know, Cisco is a major player in terms of, you know, taking this SDN platform forward for industrial IoT, right? So this shows how you have various machines having sensors and actuators, right? Um, and then you have the SDN IoT controller sitting on the top of these sensors, and then you have the applications on the top as billing and security or data analytics applications, right? So as I said here, that SDN and industrial IoT is one big thing you can see, which is coming up or which is quite emerging, right? So I think before we move on to our next topic, we'll take some break here. Okay, so we'll meet after 10 minutes. I'll stop sharing my screen, and then you can keep your questions with you. We can discuss about those questions towards the end of my session. Okay.
Okay. So we will be sharing our videos with you all on our official YouTube channel. Okay, we are continuing our session as well as we are going to take your questions also. So we can wait for some 5 minutes. Okay, thank you. Okay, all of you guys, we are going to share your with you all PPTs of all the lectures in the last day, as well as the videos of all the sessions will be here on the same YouTube channel, that is MMCA official YouTube channel. So we are waiting for sir to continue the session. We are waiting for 10 minutes, so we can continue again with the same link. Thank you.
Okay, hello everyone. We are taking 10 minutes break because sir is a bit busy. So we'll meet after 10 minutes here itself. And as this is a live session, you can ask your questions in the chat box. Accordingly, we'll be having the question answer session with the Agrawal sir, and he'll be answering you all the questions. Hello. Okay. Instead of we'll be taking 15 minutes break. You can join with the same link after 15 minutes. It's a humble request to join after 10 to 15 minutes. We'll be notifying you for the same. You can join with the same link.
Hello.
Okay, hello sir. Can we start now?
Yes, we can start. So if you wish, I can. So you want to say something before I start?
No, it's totally fine, sir. Actually, we have given the 10 minutes break to the audience as well.
Okay, no
And
problem.
some of the audience are there itself and they are watching us. So if
Sure.
you want, we can start. Accordingly, we'll be posting our messages. We have started the next session.
Okay, no problem. I'm just posting a message that we are starting.
Okay, I'll do it, sir, from my side.
There is an echo. Why?
Okay,
I think
just a
there's
moment.
con. Yep.
Let me check it, sir.
Yeah.
As well as
Hello. Okay. So hi everyone. I'm back, and I'm starting my next session on IoT and cloud. Can you keep your mic in mute? I request all of you, okay, to avoid any echo. So my sincere request to keep your mic on mute. Okay, so I'll share my screen again, and we'll start this next, topic on IoT and cloud. Okay, I'll just share. Okay, so let me share it. Okay. Very important. Now, having understood about IoT, some advanced topics on IoT, it's incomplete if we don't understand how the data is actually stored on the cloud. So, if you talk about IoT sensors, sensors connected to Arduino, and we have seen in the case of the previous topic on IoT networking, how you can communicate your data from one device to maybe another device which is remotely located, as we have seen in one example of a farm field, where you can make use of a low power wide area networking protocol to send a data from the farm field to a device which is connected to, let's say, um, a gateway device kept inside the farmer's house, and providing you some valuable information through a mobile app. So now the thing is, when you collect lots of data from these devices, so we have one aspect which is related to collection of data. So that is the task of a data engineer. So if you divide these two roles, so data engineer is mainly responsible for collecting data from various IoT sensors. Then what to do with this data? This you have to store, and then you have to analyze, you have to do data analytics on this data. So you apply basically machine learning, right? You apply machine learning tools, machine learning algorithms on the data you collect from various sensors, right? So of course, partly you can do it on the Raspberry Pi module, right, which is doing some kind of edge computing for you. But mainly we do, you know, cloud level computing or the data analytics on the cloud for the large scale data, right, for the big data we have seen. So this topic is very important. And before I start formally about cloud and discuss IoT and cloud together, I think it is worthwhile to see this analogy, right? So if you see this slide, this gives you how we used to generate electricity, right? So here the generation of electricity is shown here as an analogy, right, which is then transformed into how you have a distributed network of electricity, right? So from those olden days when we used to have a mechanical electricity generation, which you can see here, one example which is shown here on the left hand side, to how the generation of electricity has evolved into a highly distributed transmission network, right? So same is the case with the cloud. When you see the evolution from the mainframe computers to the client server kind of machines we have seen in 80s, right, to what we see now, what we see today is cloud computing, right, where you don't need to own such large mainframe computers. So the large frame computers, mainframe computers of 1960s, I mean, they were considered quite powerful in 1960s, of course. To what we see now, we have got even far more powerful computing, which is available in the form of cloud. So there is no need to own such, of course, so-called powerful in the form of mainframe computers. So you can have much more powerful computing facilities in terms of storage, in terms of processing, right, on cloud. So in a way, if you see this analogy of how the electricity was generated using those mechanical systems, it's just like owning a system for generating electricity to how having a distributed system to get the electricity, right? So same is the case here, where you have the internet acting same as like the transmission network, right? And the data is same as the electricity you have seen here, right? So you have the data which is same as electricity, transmission network, you have got internet, and all you can do is you can enjoy these resources over the cloud and do lots of computing, right? So as cloud computing has been defined, it's not a new term. If you see, the cloud computing was defined by various people. I mean, there are many great you know computer scientists who have defined this cloud computing. So one such definition, if you see, is given by John McCarthy, right? So underlying concept of cloud computing dates back to 1960s, when John McCarthy said that computation may someday be organized as a public utility. Holds absolutely true, right? So this has become now a public utility. And basically, if you think of cloud computing, it is basically making use of internet and servers, right? Remote servers to manage the data for various applications, right? So now cloud actually is a collection of various networking hardware, software, and you can say internet infrastructure that one can make use of from the cloud service providers, or as and when the requirement grows. So if you are a small company, you have certain set of requirements for these resources, for cloud resources. If you are a medium sized company, you can expect for these many resources from the cloud service providers, right? So the best part of the cloud platform is you can scale according to your requirement in future, and you can basically enjoy this pay for use and as needed kind of model. I'm not going into the details of these platforms, as you have already either studied it before, but just since we are talking about IoT and cloud together, I'm just reviewing these three platforms quickly. That you have got infrastructure as a service platform, right? Where you can see that you can have infrastructure as a server, as a CPU, right, or as a database. Platform as a service, right, where you can have basically various services, which you can see some of these services, business services, IT services, right? Or you can have software as a service platform, right? So these are the three platforms we can cover here with some examples, right? So infrastructure as a service, as I have mentioned in the previous slide, is needed when an organization is looking for the hardware, software, storage, networking, right, data center space. So you can see that this particular example of infrastructure as a service, Amazon EC2, right, Windows Azure, Google Compute Engine. So these are some of the examples of infrastructure as a service. Platform as a service, you can see platform as a service as a kind of middleware services, right? So we have seen in the slide which was showing you as a pictorial view of these three service platforms. So platform as a service could be seen as a middleware kind of service platform, right? So Google App Engine, this is one good example if you want to understand what is platform as a service, right? So when you have a software developed by you, but you want to deploy and run it on a public platform, so app is one good example which you can consider it as platform as a service, right? So yes, so if you have a software developed by you, but you want to deploy and run it on publicly available platform, then you use platform as a service, right? So software as a service is, this is like created and hosted by provider in multi-tenant model. So it's basically sitting on the top of PaaS and infrastructure as a service. Examples you can see here: Microsoft Office, right? Now, in terms of the control, this is another good slide which can provide you a clear view of, you have data, applications, runtime, middleware, operating system, virtualization, server, storage, and networking, right? All these elements. So in case of, so if you see here how customer manages, right? So you can see here cloud service provider manages, right? So when you think of what you call on-premise, right? So in case of software as a service, is the customer service provider is actually managing everything. You can see your applications, runtime, middleware, operating system, virtualization, server, storage, networking. In case of platform as a service, you have got partial control over the data and application, right? See, if it is a on-premise, then of course customer has got control over everything, right from data to applications to server, storage, and networking. Now, if you check here on the infrastructure as a service, that cloud service provider manages server, storage, networking, virtualization, whereas a customer can have a control over the applications, runtime, middleware, and OS, right? So this is how, if you are looking for your cloud services, you can enjoy one of these three depending on your requirement, right? And then the cloud service provider can provide you services. Now, the objective of this session is to introduce you to some of these emerging cloud platforms which we are using for IoT applications. So Amazon is one important cloud platform, quite widely used platform for various applications, industrial applications. So you can see that AWS or this Amazon cloud services can be used using elastic compute EC2, right? So you can make use of EC2, and you can see that if you have a model, so the model shows that how many CPUs you can use. So you can see here there are multiple models. M5.large, which is making use of 2 CPUs using memory as 8 gig, right? Storage, dedicated bandwidth, and performance. So you can see M.5X large has got more CPUs, more memory, right? So similarly, you have other Amazon EC2 models as well, right? So on the bottom, if you see that the price which you pay for each of these models, for example, if you are using M5.X large, which is providing you 4 CPUs and 16 gig memory, you pay around 20 cents an hour, 20 American cents an hour, right? So which is quite affordable, right? So Amazon Web Service is popular because of its affordability, and it's really very cost effective. Now, when you are making use of this Amazon service, you can select, the operating system. You can see here, right? Amazon Linux, Red Hat Linux, right? SUSE Linux, Ubuntu. So you can make a selection of the OS you need, right? And these are the instances when you create. You see those instances like this, right? So you can see here some of these instances running here, right? And they are named as like Couchbase server, Couchbase gateway, something like that. So when you make use of Amazon Web Service, you can see those instances running on behalf of user, right? So I request all of you, those who are listening to this session, that if you have interest in using this Amazon Web Services, you can register to AWS Educate, and you can create your account for free. You get $150 worth of cloud resources. Of course, this is a trial period. You have to make use of these resources within some trial time, right? So when you are making use of your IoT sensor, and when you want to collect the data and apply, some machine learning, or if you want to do some data analytics on the cloud platform to make it as a complete IoT platform, you can do this, right? So you can create your account in AWS, and then you can manage with your data. So that's how you manage, when you create your account in AWS. You see that you have got this um, screen. I'll show you. I mean, there is a tutorial which is available. If you wish, you can just have a tour of that tutorial, and then you can create your own file to test with, and you can delete that file as an object, right? So similarly, you can actually collect your data and store it as a .csv file, and you can do some data analysis on that, right? So when you do this, I mean, when you create your account in AWS, you see on the left hand side you have manage button, right? So under manage, you see that you have to register a thing. So as I said, like when I'm having some IoT application and I want to register my device, okay, register my device as a thing. So here you have to register that device, sensor device, as a thing, okay. You can see here that I have my sensor data which I can register as a thing here, and then I can create it as a single thing, right? Or I can create many things, right? And when you create it, you can name it. I mean, right, when you are clicking on this, create a single thing, for instance, if you select this, then it will take you to this screen where you name that thing, and then you say my IoT thing, right? And you keep it under this group, right? And then you again click next. So that's how you create that thing under AWS platform. And yeah, you similarly you can have data from various other sensors, other things, and you can work on that data. So in this, you can see that AWS platform is quite popular because it is providing you authentication, encryption, right? Good integration with infrastructure as a service. And the most important thing with the AWS platform is it is really cost effective and very affordable. And I mean, it is quite popular among researchers in universities and in research labs as well, right? In fact, one of my students in 2018, I remember, she was using this Amazon Web Services for her BTech project. So yeah, I think it is quite affordable, right? So in definitely in past few years, the price has dropped quite significantly as far as AWS platform is concerned, right? Microsoft Azure is another emerging IoT platform, right? And Microsoft has really has done a wonderful job, of course, by connecting it with academia. In fact, I was having a grant under AI for Earth in 2018, and Microsoft actually connected pretty well with academics around the world, and I was one of those lucky ones to have that Microsoft grant under AI for Earth, and I used Microsoft Azure cloud platform for my water quality project. So yeah, I worked on an IoT project in Symbiosis, and I was working with Symbiosis, and yeah, we developed an IoT solution for water quality monitoring, a low cost IoT solution, and we were aiming for our data storage on Microsoft Azure. Right, so you can see here for Microsoft Azure, you have device connectivity, you have storage as SQL database, right? Um, so the IoT hub is like that fabric which is used for connecting devices, right? So you have devices here, connectivity through IoT hub, then you have storage, SQL database, right? And you have the analytics, right? Which is providing you machine learning support to do the data analysis on the data you store here using this SQL database, right? And then you have the presentation, which is providing you, a nice visualization of the data. So it is quite important for business applications, or for various businesses, that you need to make it as a presentable kind of information, right? So when you do the data analysis, visualization is very important. So yes, Microsoft Azure provides you great support for this. So you can see here that when you use Microsoft Azure, you can make use of IoT Hub. Now I'll show you quickly how you can make use of Microsoft Azure, same as like we have seen Amazon Web Services, right? So this is the screen you see when you are having your account with Microsoft Azure, right? So you can create your account with Microsoft Azure, and then you see in your homepage, right? So you have a dashboard, you have all services, all resources, resource groups, right? SQL database, virtual machines, so etc. So you have got this homepage uh, providing you, what you can do, what you can use in this cloud platform, right? So when you click on this all services, then it opens the screen where you can see that under all services you have everything. Then you have general, compute, networking, storage, web, mobile, right? Containers, databases, analytics, AI plus machine learning, IoT, identity, security, right? And then you see here that you have got IoT hub, right? And I'm not going to talk about digital twins, but this is another emerging technology as far as Industry 4.0 is concerned, right? So those who are making, those who are working on Industry 4.0, definitely for them this would be of interest to you, right? So IoT Hub, let's see here, right? So what we do now under all services, we click on IoT Hub. You can see here that we are in IoT Hub, right? So in the previous slide, you have seen that I have this IoT Hub under this everything, right? So when I open this, I have IoT Hub. I click on IoT Hub, and using this IoT Hub, I can now register my device. So all you do is to understand how you can register your device first in that cloud platform so that you can collect your data on that, right? You can store the data in the cloud database. You don't need to worry about a huge data storage you should have. All you need is to just use cloud and send your data from the sensor, right? So if you have a video camera which is continuously sending you, a video data, you can imagine that you would require basically a cloud storage, right? So if you are working on some application, vision based application, and you are having lots of video data and you want to apply your deep learning algorithms on that data, definitely you need a cloud data storage, right? Of course, you can have your own storage, but when you have cloud, you can pay for as much as you use. Why to own it, right? Now, using IoT Hub, you can see that you can use, your um, device here. I'll show you how. Under IoT Hub, now you can use this IoT devices, right? So all I'm doing is I'm just connecting to my IoT Hub, right? Add, and now when I click here, I can then add my IoT device, right? So you can see when I click on add, I can add my IoT device. Can you see here, right? So I can add my IoT device. I can name it my test device, right? And this is relevant to the authentication, right? So I can just go with the default one, and I just save it, right? So when I click on IoT devices and I add it under IoT Hub, I can have my device added and I can collect my data. So it's just like, my device is now providing me the data which I can insert it into the Microsoft Azure database, SQL database. So yeah, Azure has got, easy device registry, right? And has very strong support for dashboards and data visualization. And most importantly, it supports real-time streaming. Now, real-time streaming is very important in IIoT applications or industrial IoT applications. I think you already have some sessions on industrial IoT, right? So if you are particularly looking for a cloud platform, Azure IoT platform could be quite suitable if somebody is working on industrial IoT application, right? So it's quite secure, scalable, high availability, right? But is expensive if you compare it with definitely AWS. So it's not like you can use AWS or Microsoft Azure, or you have Google Cloud platform. In fact, you can make use of other platforms, right? You have Cisco IoT, you have Ka IoT platform, right? ThinkSpeak, right? Yeah, many other IoT platforms one can use. Now, when we talk about IoT cloud platforms together, it is very important now to understand what are these ongoing challenges. And of course, one can pick from these challenges some important research problems, right? So real-time data processing and service provisioning is one important challenge one can see here. because when we talk about real-time data processing, it's pretty complex, right? So you need to have big data storage and processing for such real-time services, right? So real-time data is actually having a real-time constraint, so that's why it is quite challenging. And when we take IoT cloud together, this is one of those challenges which requires attention from both academia and industry, right? Um, if you see here, the it's more dynamic, as I mentioned in case of SDN and IoT also. If you see now, it is more dynamic kind of environment when we see cloud and IoT together, right? So automated provisioning of resources, or if you see resource management, this is quite challenging because of the dynamic behavior of such resources, right? So yes, I think this is one another important challenge when you look at cloud and IoT together, right? So of course, when you look at the cloud and IoT platform, it's highly distributed processing and storage of now if you have a massive amount of data, so this becomes quite challenging, right? On a decentralized, uh, uh, right? Virtualization of IoT devices, that is another important challenges when we are considering IoT and cloud together, right? Right. So access to resources, advanced resources, including GPUs and sensors, right? Um, yeah, a few more challenges like interoperability, accountability, and enabling real-time communication from objects to application and vice versa. And of course, the discovery is another important challenge. So I think this is all about IoT and cloud. When we are talking about IoT and cloud, one can understand that which cloud is suitable for you if you are having some application, right? Some IoT application. So as I mentioned that you are not restricted to using only these two, which I have covered in little detail, right? And about the AWS cloud, as I said, one can register with AWS cloud today itself, right? After the session using AWS Educate, and you can create your account. Okay. Once you create your account, I mean, I can just take you to this tour of how you can create a simple file as an object and you can delete it. I can just take you to that quite fast. Okay. So let me just take you to this AWS tutorial, right? How you can do it. So you can see here, okay. So simple storage service, Amazon SSS service, right? So this is like how you can make use of this guide and do a simple, um, I mean, you can do a simple task basically on Amazon S3, right? So when you sign up for your Amazon web services, then you can sign up using Amazon S3, right? So when you sign up for AWS, you sign up using S3. Okay. So once you sign up, you can see here how you see it, right? So sign up for Amazon S3. So this is the link you can use, right? HTTPS aws.amazon.com/S3, right? Okay. So once you choose this, I mean, once you use this link, then you can see that you are actually now having this screen, right? So you can first sign up, then you create a bucket, right? So when you create a bucket, you can see that you have this screen as name the bucket, right? And you can name that bucket. You can select this region. You have to select this region very carefully, right? To be able to use this next, right? So I think you have to use this region. Yeah, so for S3, you use this region, choose US West as the region where you want the bucket to reside. And then once you create a bucket, you can add an object. So the first thing you do with Amazon simple, SSS service or Amazon S3, right? So you first sign up and then you create this bucket and then you add your object into this bucket. Okay. So, you have created your bucket here, you can see, right? And now you add your object into this, right? So when you click on this, you can see here that you have this option as upload, right? And then you click on this upload, then you have this screen where you can upload an object, right? And uploading an object means you can add your file here, right? And when you actually, so when you see this screen, you choose add files, right? So okay, so when you upload and when you click on get started, you see here you have the screen, right? Now you add your file here. Now this is the file which could be your .csv file, for instance, or it could be any other data file, right? It could be any file which actually has the data. So you just add your file. So for example, here there is a simple example pic. This file is actually selected and it is added here. You can see here example pic. So when you click on that upload in the bucket, you add your file, and when you click on add, it allows you to select that file and then you add it, right? So it is added here. So then you can view that object, right? So once you add your object into the bucket, you can view that object. You can see here I have my object created as example slash dash pic.jpg. So you have this image and you can open this, right? So yeah, I think this is how you can add it or how you can delete it, right? So you have created it, you can delete it as well, right? So this is a very simple tutorial for working on Amazon Web Services. You can work on it, and of course, like when you have your data, definitely you are looking forward to apply some machine learning on that data, and for that you definitely need some cloud platform. If the data is not that big, of course you can do it on your edge, right? On your Raspberry Pi virtual machine, for instance, which is running on your desktop PC or on your laptop. You can do that, right? But when you have more data, when you continuously send the data for a period of, let's say, 1 month, 2 months, 6 months, for doing some substantial study on some research problem, then in that case it is advisable to make use of some cloud platform. Thank you so much, and I think you must have enjoyed this, right? And I'm now stop sharing my screen and coming back to my okay.
Thank you very much, sir, for this wonderful session. And thank you, really, thank you for that focusing on the IoT cloud challenges, because
Okay.
I think this is opening the new gate for our research scholar to dig into the IoT challenges, and you have given a right track to move ahead. I'll think in that manner.
Yeah.
Thank you
Yeah.
very much,
Certainly.
sir.
Certainly. Thank
And
you so much.
okay, and
Yeah.
we
I think now we keep it open for some questions. If somebody has some question.
yes, so we
Yeah.
have got some questions from the participants. So
Sure.
very first question is how many protocols we can use for different applications under one application? How many
Um,
protocols?
how many protocols? So I think this question should be very specific, because as I said, for WAN you have multiple protocols under WAN, right? So WAN is actually is based on wide area networking, right? So if your application has got some requirement, now if this question is particularly focused on IoT applications, so as I mentioned in my um, example, right? So when I was talking about the IoT uh, applications, for instance, if you have environmental monitoring as an IoT application, or if you have smart farming as another application, right? So in
Okay.
that case, if you consider this environmental monitoring as an application, which is actually a citywide kind of application, or maybe smart city, right? So in that case, we can consider low power wide area networking protocol for such applications. And I think I discussed three protocols here: Sigfox, LoRa, and then we have discussed about NB-IoT.
Okay, sir.
Okay.
Okay, so another question is, what is quality of service? What is QoS model? What is QoS module?
Okay. So QoS module specifically under what? Like here, when I talk about software-defined networking, I believe that the question is related to my discussion on software-defined networking. So definitely, the software-defined networking is actually aiming to improve quality of services for the user, particularly in terms of network performance, better bandwidth, and improved performance on latency. That is quality of service. There is quality of experience as well, right? So both these aspects, quality of service as well as quality of experience, both is improved. Both aspects are improved when you make use of SDN. Okay, so quality of service here is related to how we can improve on network performance using bandwidth and latency. Okay.
Okay, sir. Another question is, I'll consider, is AWS service is free or paid? And if it is free, what is the duration for the free service?
So as I mentioned, like you can just immediately go and create your account using AWS Educate, right? So I hope like all of those who have attended my session, if they don't have any account in AWS, they can make use of this AWS Educate. In fact, this was used by our students in this semester. So you can have a period of 1 month which you can use to um, enjoy $150 worth of cloud resources. I think would be enough. I mean, if you are working on some IoT based project. Okay.
Okay, sir. Another question, we have more
Anything
questions.
else?
One question is, what are the security challenges to set up the LoRa network?
Um, I mean, see, the LoRa network is definitely is set up on a gateway device, basically, right? I mean, on a sensor device or maybe on a gateway device, right? So when you have the device to device communication, definitely you need to consider the security challenges, of course, right? So of course, this is a wireless communication between two devices. So the attacker can definitely consider a denial of service attack on the gateway device or on the sensor device. So this is one important challenge a research community is focusing on, how to protect these nodes against distributed denial of service attack, right?
Okay.
Yeah.
Another question is, can we map AWS bucket or storage as a local drive like drive 1?
Um, I think I'm not very sure, because I'm not a very cloud expert. So I have just used it, for that Microsoft Azure. So I'm not sure about this.
Okay, sir. No issue, sir.
Yep.
Another question is, I think it is the last question.
Yep.
How we can use SDN in our IoT application?
Oh, I think this is a good question, and I think a very important one, because as I mentioned I mean, that discussion was very short, but I mean, my overall idea was to just, introduce the audience here with the SDN and IoT together. So one important application is industrial IoT, because industrial IoT applications have lots of latency sensitive data, right? So SDN can definitely cater to various challenges which otherwise they could face with the traditional networking. SDN has got that ability to address to network management issues, to address security and privacy issues, right? Resource utilization related issues, right? So it basically allows the best use of not only the access edge or the core network related issues. It improves the overall quality of service and the quality of experience, as I said, right? So for mission critical industrial IoT applications, the SDN and IIoT, they are now working quite closely, and SDN is definitely catering to most of these requirements of highly dynamic traffic in IIoT applications. SDN and IIoT should be the focus.
Okay.
Does it make sense?
Yes, sir.
Okay.
Okay. So I would like to say thank you very much. Thank you very much, sir. You have accepted our invitation and given a very good, conducting a very good session, technical session, I would say. And I think some of the faculty members are asking for sharing your mail ID.
Yeah, I think in my last slide I showed it. You can just, I'm just,
Okay.
can they see my chat screen? I'm just typing. Okay.
Okay, sir.
Okay. So they can use this email ID.
Sure, sir. We have got it, sir.
Okay.
No issue. Yep, sir. Thank you. Thank you very much, sir, for conducting this live session. Thank you very much. And
Okay.
for the okay. Yep,
Yeah. So
sir.
I think all the participants to listen to my session, and I hope I made it interesting enough, or I mean, I don't know.
Yes,
I
it
mean,
was interesting, sir. That's the reason we have got too many questions here in the chat box, sir.
okay. I mean, all I wanted is to provide them something which they can start with and they can use it immediately, and I can just go some important areas if they are looking forward to work on those areas through this.
Okay.
Okay.
Thank you,
Okay.
sir.
Thank you so much. Thank you so much. Okay. Bye
Okay, sir.
bye. Bye
Yep.
bye
Bye bye.
everyone.
So,
Yep.
so we'll terminate our today's session.
Yep.
We'll be sending you all the participant link for the next tomorrow's session very soon. Thank you all for joining us. Thank you, sir. Thank you.
Thank you.
Asma ma'am, your mic is mute.
Today we are sharing feedback form to you as well as the quiz, which is based upon yesterday's and today's session. Okay, fill up the quiz, and we will be back to you soon on the same YouTube channel for tomorrow's session. Thank you all. Thank you so much.